students, welcome to the lecture on advanced planning and scheduling, and after this lecture we will be able to learn the following objectives. Describe the concepts and framework of advanced planning, understand software and planning charts, describe demand and supply planning. Let's start with what APS is. APS, Advanced Planning and Scheduling System, can function in a number of environments and types of complexity. When companies start to integrate within their organization, an APS tool can be helpful because the MPS MRP, Manufacturing Requirements Planning, CRP, Capacity Requirements Planning process can take place simultaneously. An APS tool really benefits companies integrating with outside organizations. The customer and suppliers are involved in driving the organization's logistical chain. An APS system uses the following planning and scheduling approach. A planner module, which pays some attention to capacity constraints, produces a schedulable plan. Advanced planning. The role of planning in APS is to determine what demands on the production system will be met over given planning horizon. The input to the planning process includes information on manufacturing capacity and demand data. Demands may be of several types: customer orders, forecast, transfer orders, that is orders from other plants, release jobs, or replenishment of safety stock. Advanced scheduling. The role of the scheduler module in APS is to produce a detailed list of operations specifying which orders are to be worked on at which work centers and at what times. The input to this module includes all demands to be satisfied, including the internal orders added by the planner module when an end item required a component to be manufactured. It includes the current material inventory levels as well as planned deliveries or purchased materials. It also includes the same manufacturing system data as that provided to the planner module, but uses a more detailed representation of that data.
When producing to stock, meeting demands while maintaining an ideal stock supply is easier said than done. Often, overstocking or stock shortage hinder you from maximizing your profit. So how do you accurately assess demand to provide an appropriate amount of supply? If there is supply shortage, what can you do to compensate? Demand Solutions' advanced planning and scheduling synchronizes supply with demand to ensure a steady flow of revenue while minimizing supply shortage. See inventory projections that take on-hand inventory, sales orders, forecasts, transfer orders, purchase orders, and production orders into account. Easily identify potential inventory backlogs and avoid lost sales. Quickly coordinate production schedules to be in sync with demands using drag and drop editing. Predict when materials will run out in time to order replenishments and identify the impact of capacity shortages on forecasts and sales orders.
Let us now move to concepts and framework. Time in APS, Advanced Planning and Scheduling Software. The APS tools often work in what are called time buckets, which define a period of time bucketed together with no detail as to what occurs within the bucket. For example, a demand planning forecasting tool could be configured to work in weekly buckets, meaning it would create a forecast of customer orders aggregated in weekly time buckets with no distinction as to which day of the week the forecasted demand is expected to fall on. The APS framework stresses the ability to provide multi-horizon visibility. Many parts of older planning frameworks break business processes into multiple steps which are performed separately and pieced together to generate feasible plans. Constraint management. The APS framework seeks the overall bottleneck to the supply chain system and models the throughput in the system to align with the limitations of this bottleneck. Modern day APS tools not only find the bottleneck but are designed to handle situations where multiple bottlenecks exist, as well as situations where the bottleneck changes location in the supply chain over time. Features of APS. An APS system has a number of features that enable it to be clearly differentiated from traditional planning systems such as MRP, 1, 2 and DRP. Concurrent planning. In the traditional planning process, as in the case of MRP, 1, 2 and DRP, three main variables can be distinguished: demand, materials, raw materials and semi-manufactured objects, capacity. In case of concurrent planning, however, the three main variables are considered simultaneously. This results in synchronized optimal planning for the chain as a whole based on the most up-to-date data. It should be noted in this context that APS uses certain core data such as the capacity per production location and certain core constraints which are mentioned below. Constraint-based planning. A second important characteristic of APS systems is that account is taken of the constraints present in an enterprise such as capacity and materials. The APS systems use these constraints to model the production and distribution environment. The performance that an enterprise can achieve is determined by the constraints. Various constraints can be identified: material availability, available capacity, enterprise policy, cost, distribution requirements, sequencing for setup efficiency. Now we will study how to use software and plan charts. The APS has been launched independently by different software companies at different points in time. Nevertheless, a common structure underlying most of the APS can be identified. APS typically consists of several software modules, eventually again comprising several software components, each of them covering a certain range of planning tasks. In the most important tasks of supply chain planning have been introduced and classier in the 2 dimensions planning horizon and supply chain process by use of the SCP matrix. As certain planning sections of the SCP matrix, example, mid-term procurement, production and distribution, are typically covered by a respective software module. The names of the modules vary from APS provider to APS provider, but the planning tasks that are supported are basically the same. The following provides an overview of the structure of the software modules and the planning tasks concerned. Strategic network design covers all 4 long-term planning sections, especially the tasks, plant location and the design of the physical distribution structure. Demand planning. Further tasks of strategic sales planning, example, long-term demand estimates and the mid-term sales planning are usually supported by a module for demand planning. Demand fulfillment and ATP. Most APS providers offer demand fulfillment and ATP components that comprise the short-term sales planning. Master planning coordinates procurement, production and distribution on the mid-term planning level. The tasks distribution, capacity and mid-term personnel planning are often considered simultaneously. If there are 2 separate software modules for production planning and scheduling, the first one is responsible for lot sizing, whereas the second one is used for machine scheduling and shop door control. Global optimization. Old planning approaches usually generated local solutions to sub-processes which did not always combine to provide a good solution for the overall supply chain. The APS-based planning systems seek to drive global coordination and optimization of the demand and supply chains. Collaboration. The APS framework extends the supply chain by providing methods to collaborate with both customers and vendors. By clearly defining business processes and information structures, companies are able to exchange information on a planning level, much like EDI allowed companies to efficiently communication on the execution level. Supply chain modeling. The foundation of any APS tool is a model of supply chain data that represents a company's operations. An example of a graphical supply chain model is as a graph of nodes and arcs. In this case, the nodes depict plants, distribution centers, and customers. The arcs connect the nodes and represent potential transportation lanes from one node to another. Manufacturing operations at a single facility can easily be modeled in a similar fashion. APS solvers. A significant advantage of APS tools over their predecessors in planning technology is the powerful mathematical solvers that allow APS tools to make intelligent supply chain planning decisions. The term solve is a loosely used one in the context of supply chain software, but depending on the problem being modeled, a variety of optimization, heuristic, and/or statistical methods may be applied to develop a solution. Common statistical methods used by APS software include regression analysis, exponential smoothing, or Bayesian forecasting methods. Optimization methods often used include linear and integer programming. Many APS software vendors have also developed proprietary heuristics which apply rules-based approaches to solving problems. Often, a combination of these different methods is used to capture the benefits of each. APS graphical user interfaces. While the supply chain model and solvers provide the data and intelligence at the core of APS software, the graphical user interface GUI allows the software's users to interact with and interpret the information. These user interfaces, some examples of which are utilized spreadsheet like displays of information, and may also provide graphs, Gantt charts, or pictorial representations of supply chain information. Core APS modules. With the variety of software tools on the market that are considered supply chain applications, it is useful to start by defining what is meant by advanced planning and scheduling and the different software modules that can be called core APS applications. In most full suite APS scenarios, the primary modules involved are demand planning, network optimization, supply planning, factory scheduling, order promising. These modules are typically independent pieces of software that satisfy different business needs but are designed to work in concert to optimize supply chain performance. High-level designs of an integrated APS system. In most cases, the systems are designed to use the same based supply chain model data, which is often managed in a company's ERP system and brought into the APS tools through integration software. Demand planning tools typically create a forecast at the SKU, customer, ship to level and also include product family hierarchy information to allow the forecast to be aggregated and disaggregated based on business needs. Network optimization modules use the forecast developed by a demand planning and a model of supply chain capacities and costs to make supply chain design or other long-term decisions. These decisions typically involve where to locate facilities, what modes of transportation to use, and long-term sourcing decisions. The output of this tool are network design and sourcing decisions that will provide the supply chain model to be optimized on a more tactical level by the supply planning tool. Supply planning tools develop daily or weekly supply plans that satisfy customer demand based on the supply chain model developed in the network design and a combination of the forecast from demand planning and true customer demand. In essence, supply planning software figures out how much product is needed, when and where, and then determines a capacity feasible and cost minimizing plan to provide the required supply. The result of this process is a distribution plan for movement of product between locations, often called planned deployments, and manufacturing requirements called net requirements. Typically, deployments and net requirements are determined in daily time buckets for a week or two early in the plan and then later in weekly or monthly time buckets. Factory scheduling software is used to take plant level requirements from supply planning and develop a detailed schedule for manufacturing resources. Typically, companies that use factory scheduling tools are faced with either products that have a complex bill of material (BOM) and many manufacturing steps or manufacturing processes where sequencing and change over time have an impact manufacturing throughput. The output from a factory scheduling tool is sequenced work orders by each manufacturing resource. Order promising translates customer requests into promised supply dates. Once promised, order promising engines monitor progress within the supply chain against this data and provide early warning signs of potential trouble with delivery. Most order promising modules contain one or more of the following capabilities. ATP, available to promise, where projected unconsumed availability is given to customers on a first come, first served basis. AATP, allocated available to promise, where projected unconsumed availability is first allocated to demand streams or channels which are then allocated to individual demand, and or CTP, capable to promise, where production plans are recreated in order to provide supply availability to demand requests. Implementing APS software. While the integrated APS scenario presented in depicts how different APS software modules work together in a full suite solution, in reality, many companies choose to implement only some or one of the modules based on business needs. It is also common for companies to choose to implement a full suite but do so one module at a time. In practice, demand planning is the module most companies implement first. Logically speaking, sales drive supply chain decision making, and a supply chain planner must have an estimate of demand before using a network optimization or supply planning tool. Additionally, from a practical standpoint, the data requirements for DP are usually less than for the other modules, making this tool an easy place to begin implementing APS. Network optimization models are also often implemented as stand-alone models. For companies with relatively simple supply chains where there is few design or sourcing decisions to be made, the network optimization application might be left out entirely and demand might flow directly into a supply planning model. In this case, the supply planning tool can evaluate the alternate sourcing decisions usually modeled in a network optimization tool. There are also cases where the daily bucketed net requirements from a supply planning tool are adequate to communicate production requirements to manufacturing, so no factory scheduling tool is used. This often occurs when sequencing is not important or the manufacturing staff can follow simple rules to order and execute daily production requirements. Network optimization. As the name implies, network optimization tools seek to optimize performance across an entire supply chain network. Depending on an organization's needs, these tools can be used either as an integrated part of an APS system or as a stand-alone application created solely to analyze supply chain design decisions. Network optimization business case. The potential savings from the use network design software is enormous. In some cases, the payback period for a network design project can be a matter of months. Network optimization software and business processes. In the scenario where integrated network optimization software is used, a company might use the tool to make decisions on sourcing and meeting seasonal demand. Sourcing decisions trade off plant, distribution center, and transportation costs and capacities to determine which facility or facilities should supply products to distribution centers and customers in order to minimize the cost of meeting demand. Network optimization software and business processes. Stand-alone scenario design decisions evaluated using a stand-alone network optimization models typically involve capital investment decisions related to manufacturing or distribution capacity. Often this type of analysis is performed as what-if analysis. Network optimization modeling. Network optimization tools typically model the entire supply chain and include forecast information, product and facility information, manufacturing, storage and distribution rates, capacities, and costs. While integrated network optimization tools used to evaluate detailed sourcing to customer locations and location-specific inventory bills sometimes model individual SKUs and customer locations, many models to evaluate strategic decisions use aggregated data. Aggregated data is used because this reduces the difficulty of adding new plants, distribution centers, or demand for what-if scenarios, because aggregating data reduces model size and solve times, therefore allowing what-if scenarios to be easily solved and evaluated. Network optimization solution methods. The optimization methods most often used to solve network optimization models include linear and integer programming methods. Other network design considerations. User interface and reporting. The user interface and reporting features of network design tools are an important consideration when selecting a network optimization tool. Now we will discuss the demand and supply planning. Supply planning software helps companies create day-to-day operating plans by modeling manufacturing and distribution constraints and creating a supply plan to satisfy expected demand. The results of a supply planning solve are a daily distribution plan for movement of product between locations, planned deployments, and time-phased manufacturing production requirements, net requirements. Supply planning business case. The ability to develop a supply plan that improves service and reduces costs is the primary objectives most supply planning implementations. For some, developing a master production schedule for manufacturing is the primary challenge and distribution is an afterthought. A common secondary motivation to implement supply planning software is the desire to develop standardized global planning processes and performance objectives across the entire supply chain. Supply planning software and business processes. Supply planning software can be fairly considered the backbone of an APS solution because this module bridges high-level strategic planning and day-to-day operations. While supply planning is probably the most difficult APS tool to implement, organizations that successfully do so have laid a strong foundation for best-in-class performance. Supply planning modeling. At the network level, supply planning software uses a model similar to network optimization, often a pared-down version of that model-based network optimization sourcing decisions. Demand is typically a combination of near-term customer orders and long-term forecast. Supply planning solution methods. The methods used to solve supply planning problems differ with the problem being solved. Other supply planning considerations. Multi-user functionality. While other APS modules, demand plans, network optimization, and factory scheduling often function as single-user applications, supply planning software, as required by the business problems being addressed, is most often a multi-user tool. Roles are commonly divided up by facility, geography, or product line. To accommodate this, the software architecture must accommodate many users and be designed to allow users to make and evaluate changes within their scope of responsibility and also communicate changes to other users. ERP versus APS supply planning functionality. In many ways, supply planning is similar to familiar distribution requirements planning (DRP), master production scheduling (MPS), and manufacturing requirements planning (MRP) functionality available in ERP systems. The similarity between these systems is that each calculates planned deployments and net requirements. But the approach to solving these problems is notably different. In the ERP, or perhaps more correctly, MRP2 world, a MS or DRP plan is created, and after creating the initial plan, inventory and resource availability are checked to ensure that the plan is feasible. If infeasible, a feedback loop provides this information to the schedulers so they can manually create a plan that will not violate constraints. Supply planning is a quantum leap forward in that the serial planning and capacity checking process of DRP, MPS and MRP tools is replaced by a single solve. Unlike the ERP functionality, the APS solves is able to evaluate alternative options and consider costs and capacities to develop a feasible cost-optimal supply plan without iterative steps. Vendor functional specialties. Just as companies implement supply planning software for different reasons, it is also the case that software functionality and the ability to model and solve different problems using supply planning applications vary in the software from different APS vendors. Some packages focus on manufacturing and have the ability to model detailed routings and line capacities for complex production processes. Others model manufacturing rather generically. Similar differences exist in distribution capabilities, with some applications allowing modeling of different modes of transportation and carriers to be modeled while others do not. From an inventory management perspective, some packages include methods to calculate safety stock and reorder point quantities, while other packages assume these numbers are provided as inputs.
Today's complex global supply chains are full of uncertainty. The optimal supply chain is one where you can anticipate, control, and react to disruptions and volatility in collaboration with customers, suppliers, and logistics partners. That's the supply chain you get with IBM Solutions for Supply Chain Planning and Execution. The integration of planning and execution makes the difference. First, anticipate. Advanced analytics use historical and real-time execution data to forecast what will happen in the event of a disruption. Using optimization, discover the best solutions by evaluating what-if scenarios for transportation, inventory, sourcing, warehousing, and other typical supply chain problems built on the resources and constraints intrinsic to your supply chain. Now you can choose the optimal plan with optimization technology to help prescribe what should happen and determine the best alternative plan if a disruption occurs. Meanwhile, IBM cloud-based execution solutions give you control over normal day-to-day processes to fulfill orders, manage inventories, and move products. And in response to certain kinds of disruptions and demand volatility, you can have the optimized alternative plan execute automatically. In any case, with end-to-end visibility, you always have the ability to react sooner to disruptions or take advantage of opportunities. To ensure quick reaction, executing processes can be set to trigger alerts through multiple channels when things go wrong.
Now, in the end, let us summarize what we have learnt in this lecture. Supply chain management, SCM, is defined as a process for designing, developing, optimizing, and managing the internal and external components of the supply system. Materials requirement planning, MRP, and capacity requirement planning, CRP systems have been gradually developed towards closed-loop systems entitled Manufacturing Resource Planning, MRP2. The APS is a new revolutionary step in enterprise and inter-enterprise planning. It is revolutionary due to the technology and because APS utilizes planning and scheduling techniques that consider a wide range of constraints to produce an optimized plan. Supply planning software helps companies create day-to-day operating plans by modeling manufacturing and distribution constraints and creating a supply plan to satisfy expected demand.